morning, students. Today we are going to start crash course for NEET. I divided whole units, whole syllabus of 11th and 12th means complete NEET syllabus in 19 units. One by one, we will discuss each unit. I am dividing total in 19 parts. After each part's little bit theory discussion, we will solve 45 questions on each unit. And in last, we will discuss problems from 2020, what concepts we have to use to save the time. So dear students, now we are starting first unit. It is units and dimension and kinematics. In first unit, I keep two topics. Units and dimensions and kinematics. Very important topics for NEET. Every year you will get at least 2 to 3 problems from this part and not very tough. All of you are aware about units. Initially there were 3 fundamental units: mass, length and time. After they included 4 more fundamental units. Nowadays we are using SI units. In SI units there are 7 fundamental units and 2 supplementary units. Fundamental units, you know that for mass, kg, for length, meter, for time, second, for luminous intensity, candela, for temperature, Kelvin, for current, ampere, for quantity of substance, mole. These were 7 fundamental units and 2 for angle and solid angle, radian and steradian. Remember always, radian is the unit of plane angle and at one point total plane angle is 2 pi radian. And at one point in space total solid angle is 4 pi steradian. Mass, length and time, since initially there were only 3. So for all 3, remember the name of smallest unit and biggest unit. Mass, smallest unit is AMU. You are using in atomic physics. We have already discussed in theory parts. For biggest unit of mass is CHL, Chandrasekhar limit. Chandrasekhar limit. It is the biggest unit, 1.4 times the mass of Sun. For time, we are taking biggest unit century and smallest unit again from atomic physics. It is shake. When one electron in excited state jumps from low energy level to high energy level and making atom unstable, in very less time it is again jumping back to make it stable and emitting the energy level, energy difference in the form of light energy. This time is known as 1 shake, 10 to the power minus 8 second, very small time. For length, smallest unit is Fermi, again from nuclear physics, 10 to the power minus 15 meter, and largest unit is parsec. Parsec means if you take one arc of length, one astronomical unit, which is the mean distance between Earth and Sun, and keep it at a distance from which it can make an angle of 1 minute at your eye, or 1 second at your eye. 1 second, remember, that's why its name is parsec. Then this distance is known as parsec. Next, important thing is this. Sometimes in 3-4 years, they are giving such type of units which you can think it is unit of time. Like light year. You can think year means unit of time. But light year is not the unit of time. It is again the unit of distance. Time taken by light to travel, distance taken by light to travel in 1 year is known as light year. Important part is dimensions. With the help of dimensions, you can select your correct option even though you are not aware of the formula which should be actually used there. And concept is very simple. If I am asking you, tell me 3 kg plus 2 kg, what is your answer? Very quick you will say 5 kg. But if I am asking 3 kg plus 2 meter, now you cannot answer. 3 kg plus 2 meter, neither it is 5 kg nor it is 5 meter. Thing is very small, but concept is very big. See, you add 3 kg and 2 kg. What was your answer? Your answer was 5 kg. Minutely see your this equation. You can add only same physical quantities. And again answer should be same. Again answer should be same. So in dimensions, first important thing is dimensional formula. When you are writing a physical quantity in terms of your known fundamental physical quantity, that formula is known as dimensional formula. Every equation in terms of dimensions, both sides of equation, left hand side and right hand side, they should be equal. Only then that formula can be correct. Number 2, with the help of this dimensional formula, you can relate so many physical quantities. With the help of dimensional formula, you can convert one unit into another unit, from one system to another system. One by one, we are discussing these small things. I told you that you cannot add 3 kg and 2 meter in your exam. This concept they are asking in this way. They will say x is displacement and t is time, and x is equals to A plus B upon T plus C. X is displacement, T is time. Find the dimensional formula for A, B and C. X is displacement. Its unit should be unit of length. Suppose I am doing problem in SI units. So X is meter. Unit is meter and physical quantity it is length. It is length. I told you that you cannot add 3 kg and 2 meter. You can add only 3 kg and 2 kg. It means these two physical quantities should be same. With same concept, if you are adding T and C, they should be same. So what is T? T is time. So C should be time. If we are adding T and C, answer should be again time. But length can be sum of two lengths. So A should be length. Because kg plus kg answer was again kg. So A should be meter, means length. And this B upon T, time plus time is again time. It should be also length. It means A is length and B upon time, it should be length. Therefore, B should be length into time. This type of things they can ask you in exam. Dimensional formula means if I want to calculate dimensional formula for density, you should know the formula related to density. It is mass upon volume and unit of volume is meter cube. Length is multiplying thrice. So I got the dimensional formula for density ml minus 3. If I am using this sign and writing this in bracket, it is dimensional formula. In this form, it is equation of density. And powers 1 and minus 3, they are dimensions. What are they? Dimensions of mass and length in the formula of density. So in units, this type of uses are there. When we will solve problem, you will see how we can apply this. One more important thing is there, when you are calculating you are doing any experiment, definitely there are so many possibilities for errors. They can be instrumental error. Errors can be due to your carelessness. It is again a cause of error. Atmospheric conditions, so many conditions, things are affecting the final result of your experiment. So if errors are in percent, to calculate total error, we have to add all type of errors. It means if dimensional formula of a physical quantity is m raised to the power alpha, L raised to the power minus beta and T raised to the power gamma. And when measuring mass, you make an error of alpha %. And the time of measuring L, you make an error of, or alpha we are used there, so A %. In L, error was B %. In time, error was C %. So in P, if you want to calculate total error, always add the errors. It means total errors should be A alpha plus B beta plus C gamma. Total error should be this. Don't confuse with this minus. Error is error. Either it is in denominator or it is in numerator. It will destroy your result. So errors we have to add always. So this was, we have to take care of units and dimension. And when we are converting from one system to another, see, you know that 1 meter is equals to 100 centimeter. What you can observe here, if unit is small, the number which is multiplying with unit, it should be big. And if unit is big, number should be smaller. But in any case, numerical value and unit product should be same. It is the concept behind this problem. If you are going to convert, take care of this. N1U1 should be equal to N2U2. Means if dimensional formula for your physical quantity is MA, LB, TC, and in one system unit of mass is M1, length L1 time T1, another system M2, L2, T2. By this concept, numerical value in second system should be equal to, in first system, M1 by M2 raised to the power A, L1 by L2 raised to the power B, T1 by T2 raised to the power C. Getting my point? So you can convert any physical quantity from one unit to another unit. In kinematics, there are equations of motions which we are solving from 9th class. So no need to discuss much about them. You know that there are 3 equations of motion. Only you can confuse in this. Equations of motions are given by, if in 4 scientists they are putting the name of Newton, mostly students are going for that. They are confusing this with laws of motion. Laws of motion were given by Newton, not equations of motion. Equations of motions were given by Galileo. Remember, by Galileo, not by Newton. 3 equations were there. V is equals to u plus minus at. If acceleration is there, plus retardation, use minus. But it should be constant. It should not be variable. S is equals to ut. Means particle should move in a straight line with constant acceleration or retardation. Then only you can apply these results. S is equals to ut plus minus half at square. Third, means first I am writing Galileo's equations. If motion is under gravity, only replace S by H and A by G. Equations are same. Fifth, for our convenience, we make distance travelled in Tth second. It is u plus minus A by 2, 2t minus 1. So these were equations of motion. Second important thing is vectors. You know that we have three types of physical quantities. Three types of physical quantities. One, to explain the physical quantity, if we need only the magnitude are known as scalar. If you need direction also, then vectors. But direction is important, but your physical quantity is not obeying the laws of addition of vector, then tensor, like moment of inertia. In vectors, one important vector is zero vector. Zero vector means magnitude 0. Magnitude 0. What about direction? Direction of zero vector is not defined because it can take any directions. Means infinite directions are associated with zero vector. A vector is called 0 when its terminal point coincides with initial point. So from where terminal point came to initial point? When terminal point reached there, now we cannot tell. So that's why from a point we can draw infinite lines. So for a zero vector, infinite directions are possible. That's why we are saying the direction of zero vector is not defined. Is not defined. Then what is the significance of this zero vector if it has no magnitude? See, if I subtract 5 apples from 5 apples, means 5 apples minus 5 apples, what should be your answer? Is it 0 oranges? No. What you will say? Ki 5 apple minus 5 apple means 0 apple. That's why we need 0 vector. If vector A minus vector A, what should be your answer? It should be 0 vector. Next, 3 special directions are there in space. X-axis, Y-axis, if it is a plane, you are comfortable with 2 directions. With the help of 2 axes, you can explain the position of each and every point. But if you are in space, we need for height one more axis. So now we need 3 axes. X-axis, Y-axis for height, Z-axis. It means in space 3 dimensions are possible. So in these 3 directions, we are giving special name to unit vectors so that no need to explain कि we are talking about which direction. In x-axis, unit vector is denoted by I cap. In y-axis, unit vector is denoted by j cap. In z-axis, unit vector is denoted by k cap. Negative direction of x-axis minus I cap. Negative direction of y-axis minus j cap. Negative direction of z-axis minus k cap. Every vector you can write in terms of I, j and k. It means if I am saying the position vector of a point is 2 I cap, 3 j cap, 4k cap. It means if you want to reach this point, first travel in the positive direction of x-axis 2 unit distance. Then travel parallel to y-axis a distance of 3 meter. Then parallel to positive z-axis a distance of 4 meter you will reach at this point. Position vector means a vector which is specifying the position of that point. Every vector you can write in terms of its initial point and its terminal point. If you know the position vector of terminal point, if you know the position vector of initial point, you can write this vector AB. Addition and subtraction rules are simple. Add I with I, j with j, k with k, subtract in this way only. But in multiplication you have to take care. If you want to multiply two vectors, first you should know answer is scalar or vector. If it is scalar, use dot. If it is vector, use cross. If it is vector, it should have one direction. Direction is perpendicular to the plane containing A and B. Perpendicular to the plane containing A and B. And modulus of A, modulus of B, sine of angle between them. How you can calculate modulus of a vector? If you want to calculate modulus of this vector, if it is vector A, its modulus you can calculate by square root of I coefficient square, j coefficient square and square of coefficient of k. You can calculate in this way modulus. And A dot B means modulus of A, modulus of B into cosine of angle between them. But if A and B are given in terms of I, j and k, A is A1i, A2j, A3k, B is B1i, B2j plus B3k. You want to calculate A dot B. It is a scalar. Multiply I coefficients A1 B1, A2 B2 plus A3 B3. If you want to calculate A cross B, it is a vector, means it should be in terms of I, j, k. Make a determinant. First row I, j, k. If you are writing A first, then second row should be from A, A1, A2, A3, then B1, B2 and B3. Since modulus of two vectors cannot be negative, then A dot B is negative, it means cos theta is negative. It means theta is obtuse angle. If A dot B is 0, it means either modulus of one of the two or both two vectors is 0 or theta is equals to 90 degree. If A dot B is positive, it means angle between vectors should be acute angle. So getting my point? So you can calculate dot product, you can calculate cross product. See, we know that force and displacement both are vectors. But work is scalar, product of these two. Similarly, torque is a vector quantity, product of two vector quantities, radius vector and force vector. So we will use cross here. This. In solving problems related to relative velocity, only one concept is important. If you want to calculate velocity of A with respect to B, what you have to do? Add velocity of A, only one formula, and reversed velocity of B. You will get your answer. Getting my point? Only you have to reverse the velocity of B. When you want to calculate magnitude of resultant of two vector, you can use this formula. Resultant of two vector, if P and Q are two vectors and their resultant is R, you can calculate R by the law of parallelogram of vectors, which is the result of triangle of vector. What is triangle law? If more than two vectors are forming a closed polygon, see P, Q, R. You started from this point A, you move towards B, then C. AC make it closed polygon. So sum of the sides of a polygon taken in order should be equal to the side which closed it. It means R should be equal to P and Q. If angle between P and Q is alpha, you can calculate modulus of R by the formula root of P square plus Q square plus 2PQ cos alpha plus 2PQ cos alpha. If resultant is making an angle theta with P, then you can calculate tan theta by the formula Q sin alpha upon P plus Q cos alpha, P plus Q cos alpha. Getting my point? You can do this. Next, if you want to solve boat and river problems, it is a river. It is a river. If you want to reach just opposite point of the river, means at B, you should swim in this direction so that resultant of river and your velocity, it will come in this direction. Resultant should be in this direction, only then you can reach at B. You should swim at an angle theta from the vertical. Then you can reach B. But if you want to reach opposite bank in shortest time, you should swim in the direction of B and you will reach somewhere here. Is it clear? If you want to reach in shortest time, if you want to cross a river in shortest time, you should swim in the perpendicular direction of flow of river. And then you will reach at this point if river is flowing in this direction. And if you want to reach B, you should swim in this direction. And easily with the help of vector, we can calculate this angle. For shortest time, you should swim in this direction. Getting my point? Next important thing in this unit is projectile motion. When you are throwing an object at an angle theta with with horizontal, suppose with u, what will happen? Your velocity will divide in two parts. U sin theta is responsible for upward motion and u cos theta is responsible for horizontal motion. Since gravity has no effect on u cos theta, so this velocity is constant. But due to g, this velocity is reducing velocity. When it will become 0, particle will come back. Maximum distance traveled in horizontal distance is known as horizontal range. It is u square sin 2 theta by g. You can calculate this. Time taken by this projectile from A to B, it is known as time of flight. With equation of motion, we can calculate this 2u sin theta by g. Maximum height attained by the projectile in its path. You can calculate this by third equation of motion, u square sin square theta by 2g. Take care. If you cannot increase u, your power is fixed. You cannot change g because it is constant for particular place. Only if you want to increase r, you have to adjust this angle. And you know that maximum value of any angle of sine is 1. So maximum value of r can be u square by g. In this case, sin to theta should be 1. But sin 90 is 1. So theta should be 45 degree. Theta should be 45 degree. So these were some key points for this unit. So now we will try to solve some previous year problems to see how these tips are important for us, how we can solve the problems in competitive exams. Thank you. Hello students, now we are going to discuss problems from this unit, kinematics and units and dimensions. See, we will solve slowly so that you can understand well. Otherwise, problems are it is from NEET. It will not take a time more than 1 minute for you if you know the concept. See, first problem. X is equals to AT plus BT square. What is X? Distance travelled by the body in kilometers and time in second. All units are in same. No need to convert unit. We want to calculate unit of B. Concept is very simple. 3 kg plus 2 kg only can give us 5 kg. So if X is distance, it is distance. So it means BT square, it should be in kilometer because X is in kilometer. 2 kilometer plus 3 kilometer can give you only 5 kilometer. 2 kilometer plus 5 meter cannot give you 7 kilometer. So this was the concept behind this problem. So what should we be? Time t is in second. So it should be kilometer upon second square. So we are going with option C. Getting my point? In 1989, they asked so simple problem. Again, 2004 is there. The unit of permittivity of free space epsilon naught is. First thing, where you read this permittivity, it was in your 12th class syllabus. When you studied Coulomb's law, you get it there. means F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. Epsilon naught was there. So how to solve this epsilon naught? Take it on this side. Collect all remaining physical quantity on your right hand side. So what we are getting? Q1, Q2, 4 pi F and R square. 4 pi has no unit, so ignore it. Q1 and Q2 both are coulomb. Coulomb multiplying 2 times, so it should be coulomb square divided by force, it is Newton. R square, it is meter square. So what we need? Coulomb square and denominator Newton and meter square. I think you got your answer. Your answer should be C. See how simple that problem was. We are getting 4 marks for this. You will cross at least 10,000 students.